If we're multiplying inside the brackets, that's your horizontal stretches and compressions. If there's a negative in front of the brackets, that's your reflection in the x-axis, which is your vertical reflection. And if the negative is inside the brackets, ooh, big shock here, reflection in the y-axis or reflection in the horizontal direction. That's all we've done so far. We've done the translations, stretches, compressions, reflections. Let's identify them where they are in the equation. Okay, so here's everything put all together. Left to right, negative way out in front. Reflection, more specific, vertical reflection. The a value, so a multiplication in front of the function. Vertical stretch or compression, and how do you know which one it is?
Whole numbers are, non-fractions are not compressions.
Non-fractions are not compressions. Yes, could we state that a little bit better? Whole numbers are stretches. So if you need to make a note for yourself, S is the whole number. Compressions are the fractions. The negative inside the brackets. A multiplication inside the brackets. How do we know if it's a stretch or compression? Compression are whole numbers, stretches are fractions. Adding or subtracting inside the brackets?
Horizontal translation.
And the number at the very end outside the brackets, kind of all by itself, just hanging out there? Vertical translations. Flipping the page. Let's talk about the order. And I don't know why the spacing came out all weird. There's no reason. There's a space between 2 and 4 and 6 and whatever. It just happened. All horizontal stuff comes first. All vertical stuff comes last. Why?
Horizontal is always in the parentheses.
Yep. So inside, and this is your outside. What's going to come very first? It's a reflection. After reflections are your stretches, compressions. And last are the translations. Same order for the vertical. Reflections come first. Stretches and compression come second. Translations come last. Grab a sticky. All we're going to do is one example together, and then I'm going to give you lots of time to work on the homework questions. If you want to work in groups, great. Partners, great. By yourself, which you probably will, great. So you're going to work on this one, and then we'll discuss together. You might want to use pencil just in case you make a mistake, because if you make a mistake on the first graph, the whole rest is going to be wrong. So I want you to graph. Do you want to do a cubic, a square root, or an absolute value? Cubic, I love it. I want you to do -2, bracket, 1/2 x minus 1 cubed plus 4. Now, did you want to do the whole thing on your own and then have me do it, or do you want to do it graph by graph? Okay, so first thing I want you to do is draw the base graph, and then I just want you to identify the transformations. Then we'll talk before you draw. Okay, so base graph and identify. Okay, you should have the cubic as your base graph. I put a little red arrow here just as a note. What did we talk yesterday about horizontal stuff? You have to factor it out because it's going to affect the translation. So that would be step 1 before anything else. Half's going to come out front. Now be careful here. What happens when you divide 1 by a half? You end up multiplying by 2, so it becomes x minus 2 cubed plus 4. Questions on the factoring? Okay, so let's do them in order. What's going to come first? Oh, sorry, Dahlia. And you have your earphone in. We're even. Okay, what's going to come first? So H stuff's always first. No reflection inside, but that's vertical. We're going to do those after. Horizontal stuff comes first. So the half comes first. That is a horizontal stretch. XY goes to. X divided by a half, and we'd never leave it like that. What do we end up doing with the half? It ends up being 2x, and that's why it's a stretch, because dividing by a fraction actually means multiplying. Okay, so HS out of the way, what's going to come second? Two units to the right. Okay, so now all the horizontal stuff is done. Let's go through the vertical. What comes first for vertical? Reflection. XY goes to. That says X minus Y, although it's a little hard to read. Okay, after the VR, next comes. Okay, stretch or compression, how do we know? Whole number or fraction. It's a whole number, so it's a stretch. XY goes to X to Y. And the very last, the only thing that's left is the VT. 4 units. Four units. Up. Okay, so you're going to draw one, then I'll draw it, then you'll draw a second one, then I'll draw it. Again, you might want to use pencil just in case it doesn't go well. So you're going to start with the horizontal stretch. I'll give you about a minute, then I'll do it for you. Okay, so if you're a point person, you've already got your points, you've got your new points, you're drawing. I'm just going to pretend I'm not a point person and do it for the visual people. Okay, so I'm just going to go left to right. The very first X value is -2 times 2, -4. And again, if you're a ruler person, you might want to put your ruler so that you're not moving it up and down. The second X coordinate is -1, -1 times 2, -2. The third one is 0, 0 times 2. The fourth one is 1, 1 times 2. And the last coordinate is 2, 2 times 2, 4. Stop and look at it and say, did we yank on this thing from side to side? Did we yank on it and pull it horizontally? Yes. Who got that? Give me an air high five. Good. Questions? Okay, so common mistakes in there, people will take the y's and start changing them. So they'll go, well, the first y is 8, right? 8 times 2 and move it down. This has to be a side to side because it's horizontal. Okay, next up, you're going to do your HT. Common mistake for the HT is just counting in the wrong direction. That's why I like to put the mapping, well, my version of the mapping with the little arrow pointing, so it just reminds you that we're going to the right. Okay, so count 2 over, 2 over, 2 over, 2 over. Pause and ask yourself, did I pick this up and move it over 2 units? So I didn't want to yank it, I didn't want to touch the shape, I didn't want to stretch it, I just wanted to pick it up and move it. Did we do that? Mika, question?
Why is it considered to be, why is it considered to be horizontal? It's not in the brackets.
This is in the brackets.
Oh, I thought we were doing like,
No, we numbered them, so we're doing number 2 here.
okay.
Who had that? Air high fives. Good. Okay, go ahead and do your vertical reflection. Sometimes it's helpful if when you're writing out the mapping here, you put the arrow showing the direction of the reflection. For some visual people, that helps you remember you're going top to bottom, not side to side. Okay, for the ruler people, okay, we're now looking at the y value. So the first point is at -8. If I flip it above the x-axis, it's going to go to +8. Okay, next y value is at 0. Y value is at -1. Flipping it's going to go to +1. The next one is 0. Flipping 0. 0 doesn't change. +1 goes to, and I just realized I picked up the red pen, which I totally didn't mean to do. And -8 is going to go to +8, which I can't see where that is. So ignore that that's in red, not supposed to be. Who had the correct vertical reflection? Awesome. Okay, vertical stretch. Go to. Okay, so now we're going to take those y values and multiply by 2. So starting on the left-hand side, right now it's at 8. 8 times 2, 16 off the graph, so I don't need to worry about it. Now I have a y value of 1. 1 times 2, 2. 0 times 2, -1 times 2, and -8 times 2, off the graph. Okay, pause and ask yourself, did I stretch this vertically? Did we take the top and bottom and yank on it and make it skinnier? Okay, 1 to go. So this will now be the red one. Go ahead and do your vertical translation. I have a feeling some people are already done. Translations are the best one because it's just counting. So 1, 2, 3, 4. There it is, and I'm just going to highlight it so you can see it really clearly. There you go. Now, I've had a lot of people complain, well, there's no answers in the back of the book. Well, you have a method to check this. How can you check it? Yeah, you got your calculator, right? So you can put this right into the calc and you can compare. You should have the exact same last graph that the calculator has on its screen. So let's check. Let's see if we did it right. Okay, you tell me what to type in. Yes. Yes. Talbot's carrying the team here, guys. How do I do a cubed? I can't find a cube. There's no cube button, Mrs. Thompson. I'm lost. I don't have a YX button. Oh, what? The what button? Could we call it by its real name? It's carrot. It's called a carrot. Yeah. We use it in computer science all the time. C-A-R-A-T. It's actually carrot like gold. No, is carrot with gold with a K? It's with a K. Carrot like diamonds? Are carrot diamonds with a C? Yeah, there you go. Carrot like diamonds. And we want to check this. Oh, we haven't gone there yet. I'm just still on this screen, just you're a step ahead of me. Does anyone want to check, make sure I entered this correctly? You want me to move down? We're only doing one graph, so no y2. Really, would you like to check again to make sure I put this in correctly? So look at yours, look at mine, look at yours, look at mine. Okay, so we're going to go zoom, and we're going to pick. Oh, what? You tell me it was right. And so when we get an error like this, what's the best choice here? We don't want to quit, we want go to, because the calculator's pretty smart and it will start flashing on what it thinks the error is. What did none of you catch? Oh. Oh. How can you tell visually what's the difference between them? The subtraction is longer and lower. This is a negative key. Minus is subtraction. So this is the negative key. Yeah, but then you didn't catch mine. Shame. Okay, so we want to compare how we do. Not bad, not bad. So there's our red one there. Let's just grab the calendar and talk about what's coming up, because we've had a date change and some people were confused where we are on the calendar. So grab yours.